Hey guys, this is the Edexcel 2019 AS Level Maths paper 2, which is mechanics. Number 1. At time t equals 0, a parachutist falls from rest from a helicopter which is hovering 550 meters above horizontal ground. The parachutist, who is modelled as a particle, falls for 3 seconds before her parachute opens. Before her parachute opens, she is modelled as falling freely under gravity. Acceleration due to gravity is modelled as 10 meters per second squared. Part A. Using the model, find the speed of the parachutist at the instant the parachute opens. Okay, so she's starting at rest and accelerates by 10 meters per second every second. So her speed is 3 times 10 meters per second, so 30 meters per second. When the parachute is open, she continues to fall vertically. Immediately after the parachute opens, she decelerates by 12 meters per second squared for 2 seconds. She then reaches a constant speed and reaches the ground with this speed. The total time she takes to reach the ground from the helicopter is capital T seconds. Part B. Sketch a speed time graph for the motion of the parachutist for t between 0 and capital T. Alright. Okay then, so first of all, draw yourselves some axes. Don't forget to label them speed and time. So, first step, we know she starts from rest and after 3 seconds reaches 30 meters per second. So, something like that. I'll put the numbers on in a moment. Now, she decelerates for 2 seconds at 12 meters per second squared. So, after 1 second, she's going to be down to 18 meters per second. After 2, she's going to be down to 6. And then from there, she stays at that speed until she reaches the ground. Okay, now let's put the numbers on. So, we know this speed was 30, and then this one was 6. Now, this time was 3 seconds. This one was 5. And then she reaches the ground at t seconds. So, there it is. C. Find to the nearest whole number the value of t. Alright, so on a speed time graph, area under the graph is the distance. travelled. So, we know the total area is 550. Let's break it into 3 separate areas. So let's call them A, B, and C. Now, we know that A, being a triangle, is 30 times 3 over 2. So that's 45 meters. Now, B is a trapezium with a height of 2. So his area is 2 times 30 and 6 all over 2. So that's 36 meters. Now C is a rectangle. So that's 6t. No, it's not. Sorry. The base of the rectangle is t minus 5. So that's 6 lots of t minus 5. Okay, now we know those added together equal 550. So, we gathered 6t. Now we have 45 and 36, so that's 81 minus 6 times 5, so minus 30, so that's going to give us add 51 is equal to 550. So 6t is 499. Divide by 6 and to the nearest whole number. T is 83 seconds. In a refinement to the model, the effect of air resistance is now included before a parachute opens and a new value of T is calculated. But D, how would this value of T compare with the one we just calculated? So, air resistance slows you down, so in the new model, speed after 3 seconds is going to be slower, so after 3 seconds she would have fallen less distance, so it's going to take her longer to reach the ground. So this new value of T will be larger than the one we just calculated. And the final part wants us to suggest one more refinement to the model. So there's quite a few things we could say. It's highly unlikely she's going to be falling exactly vertically. There will be some sort of horizontal motion too because of wind. We modelled her as a particle, so take into account that she's not a particle, she does have dimensions. gravity we took as being 10, so we could be more accurate with that. Anything along those lines, and you are cool. Number 2. A small ball P of mass 0.8 kilograms is held at rest on a smooth horizontal table and is attached to one end of a thin rope. The rope passes over a pulley which is fixed at the edge of the table. The other end of the rope is attached to another small ball Q of mass 0.6 kilograms, which hangs freely below the pulley. P is released from rest with the rope taut at a distance 1.5 meters from the pulley and Q 0.4 meters above horizontal ground. Ball Q descends, hits the ground and does not rebound. The balls are modelled as particles, the rope as light and inextensible string, and the pulley as small and smooth. Using the model Part A, show that the acceleration of Q as it falls is 4.2 meters per second squared. So to start off, we need to think about what forces we have going on. So let's start with tension. So tension is trying to pull Q upwards. Now that same tension is trying to pull P to the right. Now, at P, we know there are no resistant forces because the table is smooth and the ball is modelled as a particle. So, in fact, the only horizontal motion acting on P is tension. While we're here though, we will also mention that P does have a weight, so that's going to be 0.8 G. So at P, remember we know force is mass times acceleration. So at P, we know that 0.8 A which is the force is also equal to tension. Okay, now let's think about Q. Okay, so we already know Q as tension trying to pull it up, but we know its weight is winning because Q descends. So Q's weight is 0.6 G. Okay, so the resultant force at Q is 0.6 G minus T. So at Q, mass times acceleration is 0.6 A. And that is equal to 0.6 g minus tangent. Okay, so we can now treat these as simultaneous equations. We want to get rid of t, so if we call them 1 and 2, and then we need to add them together. So we get 1.4a is equal to 0.6 g. Now, divide through by 1.4 and we get a is 0.6 g over 1.4. Now, use g as 9.8 and we do indeed get 4.2 to 1 decimal place. B. Find the time taken for P to hit the pulley from the instant it was released. So this is quite tricky. There are two parts to this. There's part of the journey while Q is falling and accelerating, which is also going to make P accelerate. And then when Q hits the ground, P will stop accelerating, but because there's no resistant forces on P, it will then continue to move at a constant speed until it hits the pulley. So, first part then, while Q falls. So, what we can do here is find the time that it takes for Q to hit the floor. So, we're using suvat. So, S, if we take down as positive, S is 0.4, U is 0, we don't know V, we don't care about V, we know A is 4.2, and we want T. So, the guy we're going to use is S is a UT and 1/2 AT squared. Okay, so we got 0.4 is equal to 1/2 times AT squared, so that's 2.1 T squared. Divide by 2.1, we get 0.19, is equal to t squared. Square root, we get t is 0.44. So, what we can do now is find how far p has travelled in those 0.44 seconds, calculate its speed, and then calculate how much longer it's going to take to hit P at the pulley. Let's now say this is then P after 0.44 seconds. So, we need to know its displacement, but we don't know it. So we're going to work it out. We know the u is 0. We don't know v, well no, we do care about v. So, we'll have v as an unknown. We know its acceleration is 4.2. And t is 0.44. Okay, so again, we're going to use s is ut add half t, sorry, 1/2 at squared. So we get s is 1/2 times 4.2, so 2.1 times 0.44 squared, which we know is 0.19. Now that is going to give us the one decimal place 0.4 meters. So, after 0.44 seconds, P has 1.1 meters left to travel. So, we now need to calculate what its velocity or speed after 0.44 seconds was, and then we used speed is distance over time. So we can now use v squared is u squared add 2as to work out the speed of p after 0.44 seconds. So v squared is 0 squared add 2 times 4.2 times 0.4. Now that gives us v squared is 3.36 meters. Oh, just 3.36 for now. Square root, and we get v is 1.83 meters per second. So what we now need to work out is how long does it take P to travel 1.1 meters going at 1.83 meters per second. So we now want to do, well, we know speed is distance over time. Time is distance over speed. So 1.1 divided by 1.83 and that is going to give us 0.6 seconds. So the total time we're finally there is the 0.44 seconds add 0.6 seconds, and that is 1.04 seconds. Very tricky. In the final part, state one limitation of the model that will affect the accuracy of your answer. So the biggest one was that we didn't take any resistant forces into account. So there would have been air resistance, there would have been friction, nothing is perfectly smooth. So without those, our answer really is inaccurate. Now the final question, a lot nicer than the other two in my opinion. So a particle P moves in a straight line so that its velocity at t seconds can be modelled as v is 12 add 40 minus t squared. Part A. Find the magnitude of the acceleration when P is at instantaneous rest. Okay, so rest means that V is equal to 0. So that means 12 add 4t minus t squared is 0. So we're going to factorise that. So that's going to give us so it's going to be a combination of 6 and 2. Now we want a plus 4, so it's going to be 6 in there, so then we get 6t and then a plus 4, sorry, plus 2 in there, so then we get minus 2t. So that tells us t is, well, it's either positive 6 or negative 2, but t is greater than or equal to 0, so t is positive 6 only. Okay, now we need to find acceleration, which is the derivative of velocity. So, acceleration is dv by dt So that is 4 minus 2t. Now, the acceleration when t is 6 is then 4 minus 12, so minus 8. But we want the magnitude, so the absolute value. So the magnitude of the acceleration when t is 6 is positive 8 meters per second squared. Part B, find the distance travelled by P for t from 0 to 3. So, displacement is the integral of velocity. So we want the integral between 0 and 3 of v dt. So that's going to give us 12t add 2t squared minus t cubed over 3. Between 0 and 3. So when we plonk 0 in, we're just going to get 0. So we just get 12 times 3 is 36. Add 2 times 3 squared, so that's plus 18. And then minus 27 over 3, so that's 9. So we get 45 meters. Okay then guys, that's the end of that one. Really hope it helped. Remember, I have so much AS Level Maths revision resources and content on the channel, so make sure you check those out. Good luck in your exams. For now, take it easy, take care.